invitation today and talk about a topic very near and dear to my heart, this whole penogenesis thing. And especially a shameless plug amongst the students in the room here. If you want to learn more about these soils that your plants are growing in every even spring semester, or I'm sorry, fall semester, so upcoming fall 26, I teach a class on soil genesis, morphology, and classification. So a lot of what we'll go over here, obviously that class is not Illinois centric, but we talk about all this stuff and how it all works and where those soils come from. So stop by and find out about that. Really good combination of stuff. But yeah, so I'll talk about the major soils here in Illinois and where those come from. Let's see if this thing turned on. Not getting
let me help. I'll select.
Okay. All right. Yeah, so okay, I have to run from over here, it looks like. But all right. Gotta get out of that light though. You weren't kidding about that light. So when we talk about soils, we have what we refer to as our 5 soil forming factors. These are the things that come together to influence what we find in our soils at any given place on the landscape. And so those factors are parent material, organisms, climate, topography, and time, as you see there. And then we refer to the 5 soil forming factors because there's 5 that are defined. Notice there's a 6 up there and a ... And what that tells us is that we actually, in any given location or situation, might have some other things that come in as well that are also influential. So the 5 soil forming factors, those we view as being universal, and then the ... those are anything additional that's important to our particular area. A really common modern ... is humans. We have done a lot to influence soil and the properties that we see in soil at any given point in time. Now, of these here, they should be fairly, in most cases, fairly obvious what they are, but the parent material, that is the geologic material in which our soils form. And so James's talk was a really good introduction into some of that for the state of Illinois, what we find where. Organisms, sometimes you will see that listed by people as vegetation. I don't really like vegetation, and I don't mean that in the sense of I don't like plants, but vegetation is a really limiting term. We have a lot of microorganisms that are really important in soil formation. We have a lot of macroorganisms, termites, earthworms, ants, that are important in soil formation. It really is more of an ecological perspective on that, as opposed to being just like the plants that grow in a given area. So that's why I don't like using vegetation as a soil forming factor term. Climate, of course, how much rainfall we get, how the temperatures are, ranges, all that kind of thing. Topography is more than just highs and lows. It actually does involve where you're at in the landscape. It involves the aspect of the location. You get very different soils on a north versus south facing slope, for example, within a given location. And time, how much time that soil has had to form. These things all come together to work out what we're seeing at a given place. Now, those are external factors, and those external factors influence internal processes. So we take that parent material, and to that parent material, over time, we will add things to it. We will remove things from it. We can have translocations. That means moving things around within that soil profile. And we have transformations, changing things from one type of material to another. So in our pedon right here, pedon being a unit of soil that we can define on the landscape, you'll see examples of that. With the additions, plants are really important in a lot of our additions in our soils. Up at top there, you'll see there's an arrow pointing in. And one of the very first things that happens to create most soils in the world is we add organic matter. Okay. So yeah, we start to get life. Things start to grow in that soil. As those things die, they add organic matter to the soil, and that's the first step of petagenesis in most cases. You all also notice there's an addition from down below up here as well. So we can have groundwater move up into the soil, dissolve materials in that groundwater. As the water moves back out of it, things get left behind. Losses, erosion from the top, losses of organic matter through decomposition. We can leach things through the soil, so losses at the bottom. Translocations, moving things around within the profile itself. Really common translocation is taking clays from our shallower parts of the soil, moving those clays down into deeper parts of the soil and accumulating them in that deeper part. Lots of other translocations too. Transformations, that's mainly chemical. We take what we call primary minerals, minerals that are inherited from the parent material, and we chemically alter those into other minerals. So really great examples involve taking minerals that have, for example, iron in them and stripping that iron out and creating iron oxides and transforming those primary minerals into clays over time. So those kinds of things happen. We have those 5 external factors. They work, the soil forming factors, they work on the given location, create these internal changes, and boom, we get a soil on our landscape. Now, within Illinois, here is the distribution of soils within our state. And so we have a lot of alpha-sols and mollisols. Alpha-sols being the lighter browns you see in Southern Illinois, wrapping up around the western part of the state. The mollisols being the darker brown colors you see up here, especially in the northern and eastern part of Illinois. Then we have some intasols and septasols, the yellows and greens. Those, a lot of those are flowing along streams within the state, and they show up really well down here in the south. We have less well-developed stream systems up in northern Illinois, especially in that Wisconsin and glaciated area that James showed us earlier. We get a lot of what we call closed depressional topography in that part of the state, and so the stream systems aren't as well developed. You don't see those intasols and septasols showing up quite so well in that part of the state. We have a few other things that come in as well. The histosols, the alphasols. We'll talk about alphasols in a minute here, because those are really interesting to me here in Illinois. But that's how our soils are kind of distributed. Alphasols and mollisols dominate our soil world in the state of Illinois. We can relate those back to some of these soil forming factors. So we'll start off here with our map of our quaternary deposits, the things that we find at the surface in our state. And because geology is very important as a parent material, notice that a lot of that dark brown from the mollisols is centered on those greens that represent the Wisconsin and glacial advance, that most recent glacial advance into our state. And in fact, see what the county's drawn on here. You look at the county lines over there, the mollisols, you look at the county lines here at the southern end of the glacial advance on this side of the map, they match up almost perfectly with where you see those. The other thing that's really super important is even a better correlation here in Illinois to our soils is the native vegetation. And so this is a native vegetation map from the NRCS. And you look up there at those oranges, those are our prairie areas. Compare the orange to the dark brown over there on the first map, and how that lines up. And even if you look down the side here, the eastern side of Illinois, you'll see a few pockets of prairie, along that eastern border zone. And if you look over here at the soil map, you'll see those same pockets of dark brown trailing down along the eastern boundary of Illinois. So, very good, a very good correlation there with the native vegetation. Now you'll notice it's not a perfect correlation. If we look at the woodlands, we have a 46% of our native vegetation, our area covered by woodlands. Look at alphasols, they're 45%. That's pretty good. But we also see a lot of prairie vegetation is 40, mollisol is 43. So it's really close. It's not perfect, but it's really close. We get into areas like savanna. A lot of times we'd expect to see alpha sols in savanna as well. That is another 10% to the woodlands if you're looking at it from that perspective. Here's the 56. Now our correlation starts to fall apart a little bit. But if you look back down here in the part of the state where those woodlands are really common, the forests are really common, we see that we've got the entosols in the yellow, we got the inceptosols in the green. That's about 9%. And all of a sudden those start to come back together again more closely. We'd expect to see alpha sols in that area, except that we've got a parent material difference and we got a time difference that comes out right here. Notice that on our geologic map, those areas that show up as the entosols and the inceptosols on the soil map, as we mentioned earlier, those are following along a lot of our river valleys within the state, and the materials, the parent materials in those river valleys tend to be much younger than the parent materials that we see where we've had glaciations. For example, we got the older glaciations down in the southern part of the state and up the western side. Also, this map doesn't show it really well, but a lot of that Illinoisan glacial material at the surface is actually covered by a thin layer of loess. You look across Illinois, we got 1, 2, 3 feet of loess that covers a lot of that across the state of Illinois. So, but anyway, you take it all, you put it together, you can start to tease these things out, and it makes a lot of sense. The percentages, when you look at these three together, the soils, the parent material, the time implied by some of the parent materials, and that native vegetation, you can explain really, really well. I get, if I had put all this together and gotten an R squared for you, you'd be really happy with your R squared that comes out of putting all those three things together and seeing how they relate. So it's actually very predictable what we're going to find where based on these different things. Just looking at it a little bit more again in terms of the distribution, and look a little bit at some of those final ones. The altisols, which I mentioned, those are really interesting to me, that we have them here in Illinois. You can't see them really well on the map. They're less than 1%, so that orange doesn't really pop out. But if you zoom in, you can find, we got some oranges down in here, you got some circles that show some of the places in the state where we have those oranges, right down here in the extreme south. And you might remember again, if you go back and look at some of the maps that James showed us, we have bedrock at the surface down in this part of the state. Those are our oldest surfaces within the state of Illinois. That means that we have the potential, at least, for those areas to be the places where soil formation has occurred over the longest period of time. And of these soils that we're talking about, altisols are our most weathered. They take the longest amount of time to form. They have to have stable surfaces over prolonged periods. Also typically associated with subtropical climate. Okay, that's where I say they're really interesting here in Southern Illinois. But if you go and start looking at Köppen climate classification, we actually are a subtropical climate in Southern Illinois. That's where we map out as. These are really common across much of the Southeast. You go through, if you go down into like Alabama and Georgia and Mississippi, and they're famous for their red soils, and most of those red soils are actually altisols. So we have a little bit of that in select locations here in Illinois. So a little bit of a closer look at what some of these soils are, what those properties tell us about them, what you can do with them. Our mollisols dominate the northern and central parts of the state, as we saw on the previous maps. These soils tend to be younger than those soils that we find down here in the south or along that western wrap up, where we have the Illinoisan surfaces present at or near the surface on our landscapes. One of the big things that marks mollisols is a really high organic matter content. And if you look at the profile right here. Notice that all the way down to about 12 or so inches on that scale, we got a nice dark color in the surface of that soil. Okay, we call a molic epipedon. In the world of soil science, the mollisols come from the presence of a molic epipedon, a molic surface horizon. These soils are characterized by high fertility, by a high base saturation status. And we mean by high base saturation status, if you, just in case you're not familiar with that terminology, we look at our basic cations, which would be things like calcium, magnesium, potassium, sodium, in our soils, and we're looking at, what's the ratio of those to our acidic cations, our aluminums, our irons, our hydrogens, and so we're going to have a high content of those basic cations in these soils. Those basic cations tend to be plant nutrients that are really, really important. So you guys probably, maybe I don't know if you use the same basic and acidic terminology or not in what you do, but not shocking if you do. So we have that high base cation, base saturation status, high organic matter content. That means really fertile. And so when people think about the Midwestern United States and refer to it as the breadbasket of the country, these mollisols are what a lot of people have in mind when they envision that, that breadbasket concept. This is also, if you've heard the terminology, very common here in Illinois. If you've heard like local farmers or anyone else in the area refer to the flat black, this is the flat black. Okay, pretty flat landscapes, pretty not a lot of elevation change from place to place. The black means that dark surface horizon. I had a group of my graduate students. We went up to a conference about a year ago in Champaign, and as we were driving up the road, it was wintertime, and so the fields were pretty exposed. You could really see the soil in a lot of the fields. And I pointed out the window to some of my students who are from all over the world and said, "Look at the color of that soil." And one of them started filming it. He took like a little video and sent it home to his dad, who's also in agriculture. And he said, "Can you believe this soil?" Never seen anything like that before. So we kind of take it for granted because it's here. We've got it. It's a part of what we are. Most of the world doesn't have these. There's three major mollisol belts in the world, right here in the Midwest, that Ukrainian-Russian steppe region and the Argentinian Pampas region are the three major mollisol belts in the world. They're actually fairly unusual, or at least pretty special. As we come into the other parts of the state, the other major soil that we saw was the alpha sols. Were roughly evenly split between mollisols and alpha sols. The two of them combined make up almost 90% of our soils here in Illinois. The alpha sols have typically been forming for a longer period of time. They're more weathered. They're marked. One of the big differences between the alpha sols and the mollisols is the alpha sols have a lower organic matter content and a lower base saturation, so they don't tend to be quite as fertile. That being said, they are a major agricultural soil worldwide. We have more alpha sols across the world than we do mollisols, so they are frequently utilized in agriculture. But here in Illinois, all the farmers that have alpha sols are envious of the farmers that have mollisols. Okay, just not quite as good in the world of agriculture. Flip side is native vegetation, as we saw earlier, tends to be forests, really good for agroforestry or other forestry type applications. And of course, as you look down here, we got the national forest and we got, any of the logging industry in the state and that kind of thing. It's down here where the alpha sols are at. Do notice in the picture here that surface horizon up there, I can't get there at the top, right below the Sisney sign, which Sisney is the name of this particular soil. It's the Sisney soil series. We name our soils in the world of soil science, just like the geologists name their rocks. And but this is a Sisney soil, one of the more famous alpha sols here in Illinois, gets a lot of attention. But you can notice that surface horizon, it is dark, but it's much thinner than the horizon that we saw on the previous soil. That, by the way, was a drummer soil. Drummer is the state soil of Illinois. That mollisol picture that I showed you, that's drummer. So But we go rapidly from that dark surface horizon into a very bleached looking, horizon. Then below would be what we call an E horizon. The dark colored horizon is an A horizon. That bleached horizon is an E horizon in soil science parlance. And that is where we've had intense leaching take place. And we've lost pretty much everything that gives that soil color. We've also leached out a lot of the nutrient content from that horizon. And then we get down to the B horizons down here below where we're accumulating things. But back to these are not as fertile in the world of soils as those mollisols are. Inceptisols and entosols, those soils that we found within the the stream drainage ways that we saw, the stream valleys, these are younger soils. They typically have not had a lot of time to form. I always tell my students the entosols are the infants of the soil world, and the inceptisols are the teenagers of the soil world. Okay, so not quite fully formed in a lot of sense. Two big reasons this happens. One is just time. In some cases, if these soils are allowed to sit there for a few hundred or thousand more years and nature does its thing, they'll become something else, a mollisol, an alpha sol, a whatever that area is well suited to. The other reason that they are entosols or inceptisols, however, and especially the entosols, is we have a frequent resetting of the pedogenic clock. And this diagram here, this image here shows that frequent resetting really, really well. Notice we have lots of thin, dark layers that go all the way up from the bottom to the top of this picture with lighter colored bands in between them. So dark band, a light band here, dark band there. You're looking at a floodplain. And so we had a flood, it deposited material, the soil started to form, another flood happened, it deposited material, soil started to form, another flood happened. We keep resetting the clock. We don't give the soil a chance to really get going. Okay. And so that's a really great example of that resetting of the pedogenic clock perspective on the entosols. We do see a lot of mixed uses. They can be used for agriculture, usually aren't as fertile again as certainly the mollisols. Can be used for agriculture, can be used for forestry. Most of them here in Illinois are down in the southern parts of the state where we have forestry is a thing. The agricultural front, we even have some of these being farmed to rice along the Mississippi River Valley here in Illinois. So, but these are the soils that have the rice farming going on here in the state. And the altisols, as mentioned, they tend to be the most, they're the second most weathered of our soils. We do have oxasols in the tropical regions, but no oxasols in Illinois. So these are the most weathered of our soils here in the state. Typically, it's going to have to take a long time to form. Organic matter is pretty low. Base content, base saturation is quite low. Natural fertility on these is quite low. And so it's not really, from the farmer's perspective, it's probably a good thing we don't have a lot of these in Illinois. They're not the best soils out there from a farming perspective, but they're interesting. From a soil scientist perspective, to be in the world of altisols is interesting, especially a Midwestern soil scientist, because they're not a common thing in our part of the world. So that's a really quick 30,000-foot view of the soils here in the state of Illinois. And I'm open to questions. Anyone has questions?